Hi, good morning everyone. In this video, we'll continue with electric circuit analysis, some more definitions. So, in this video, we are going to see about what is meant by passive element and active element. Similarly, what is meant by bilateral element and unilateral element. These four definitions we will discuss in this video. Later on we will move to the other topics. So, passive elements and active elements, bilateral element, unilateral, these are the important concept in your ECS subject, and sometimes they may ask you to explain or write a difference between passive element and active element, bilateral element or unilateral element. So, you have to know about passive element, active element, bilateral element, how it will be there, right? This is a very important question. 2 or 3 times they ask in your main examination also. Passive elements, the elements which receives the energy is called passive elements. The element which receives the energy, the elements which receives the energy is called passive element. So, example for passive elements are resistor, inductor, capacitor. So, this is called passive element. So, what you have to remember here is receive. The elements which receives the energy from external source is called passive elements. Example for passive elements are resistor, inductor, capacitor. Next, coming to the active elements, the elements which able to delivers the energy to external source is called active elements. The elements which delivers the energy to external external circuit is called active elements. Here we have to remember delivers the energy. So, example for active elements are voltage source, current source, voltage source and current source. So, it may be constant voltage source or alternating voltage source, and similarly constant current source or variable or alternating current source. So, this is about active elements. So, what is meant by active elements? The elements which able to deliver the energy to external circuit is known as active elements. Example is constant or alternating voltage source or constant or alternating current source. Simply we can say example for active elements are voltage sources and current sources. So, this is about active elements, right? Next, coming to the bilateral elements. So, this is which is a very important to know about a bilateral element. What is meant by bilateral element? An element which conducts current in both the directions. Is known as bilateral elements. The elements which conducts both the directions. Suppose if you take resistor, inductor, capacitor, so which conducts, so these are the examples for bilateral elements. So these are LC, resistor, inductor, capacitor, which conducts in both the directions. So it may conduct, current will flows in the direction, also current will flows in the direction. If you connect like this, current will flow. Similarly in inductor and capacitor also. What is meant by bilateral elements? The elements which conducts current in both the directions is known as bilateral elements. Example is RLC, right? Resistor, inductor, capacitor, example for bilateral elements. Next one, coming to the unilateral elements. So, unilateral elements quite opposite to the bilateral elements. it means the elements which conducts current in, or which allows the flow of current in only one direction. The elements which conducts in only one direction, or the elements which allows the flow of current in only one direction, is known as unilateral element, right? So a best example for unilateral elements are diodes. Best example is diode, transistors, and some of the semiconductor devices. So these diodes are conducts in only one direction. Diode will have two terminals, one is anode and another one is cathode. If you connect a positive terminal to the anode and negative terminal to the cathode, then only this diode will on. That means the current will flows from anode to cathode. If you connect negative terminal anode and positive terminal cathode, like this, if we connect, so this will be this diode will be in off position. That diode will not conduct. That means the diode is in reverse bias. So this is the example for unilateral elements. So in next video, we will see about so in this video we will see about what is meant by ideal, what is meant by practical sources. Okay, here what is the ideal voltage source and what is the practical voltage source, we will see here. Ideal voltage source, so it means one which maintains a constant voltage at its terminals, irrespective of current delivered to the external network. So example, here we can see the one simple circuit for ideal voltage source. So here source voltage is Vs. So these are the terminals. So here source voltage is Vs and terminal voltage is Vt, right? In ideal voltage source means which maintains a constant voltage at its terminals. So here in this ideal voltage source, Vs is equal to Vt. So in ideal voltage source does not have any internal drop. Vs is equal to Vt. But if you take practical voltage source having some internal resistance, so here you can see this one. So this is the practical voltage source. So here Vs. So this is resistance of the voltage source, internal resistance of the voltage source. So if you calculate the terminal voltage is not equal to source voltage like ideal voltage source. The practical voltage source which have internal resistance, the terminal voltage Vt is equal to Vs minus Is into Rs. That is the drop. So that is called practical voltage source. So practical voltage source which have internal resistance, the terminal voltage and the source voltage is not equal. So this is about practical voltage source. So in graph way, in this graph also, so we can see the how practical voltage and how ideal voltage sources we can represent. If you take Is is in x-axis, voltage is in v-axis. So in ideal voltage source means Vs will be constant. So this is the ideal voltage source, and practical voltage source is when current is increases, this source voltage will reduce. This is the practical voltage source. Practical voltage source graph representation, right? So this is about voltage sources, and next we will go to the ideal and practical current source. So what is meant by ideal current source? Ideal current source. Ideal current source is one which delivers a current a constant magnitude. So output current and input current will be same. So here if you take one circuit, so this is source current, this is terminal current. So here the Is is equal to It in ideal current source. Ideal current source means the source current and terminal current both will be same. Coming to the practical current source, every current source will have some internal resistance. The terminal current and source current will not be equal. So this is the source current and having internal resistance. So here, so current will flows internal resistance also. So here terminal current It. How we can write It is equal to, or Is is equal to It plus, so this one V terminal voltage is Vt by Rs. So if you take terminal voltage Vt is here, the current flowing in this path is Vt, current flowing in the resistor path is Vt by Rs. So if you compare these two equations, what difference we are getting? Ideal current source is constant current source. So here terminal current and source current will be same. Coming to the practical current sources, the source current is equal to terminal current plus resistive drop, current flowing in the resistance Vt by Rs. So this is about ideal and practical current sources. So coming to the graph of ideal and practical current sources. So if you take terminal voltage in x axis and in y axis current, so here ideal current source is like this, a constant, and practical current source is when Et is increasing, Is will be decrease. Here It will be decrease. So here It is equal to, what is the practical current source terminal current? It is equal to Is minus Vt by Rs. That's what terminal current will decrease when Vt is increases. So this is about ideal and practical current sources. In next video we will see the dependent and independent sources. Thank you everyone.